So what we're doing here is we're gonna first of all let's go put a grid together. And what do you we'll say display grid. We'll go ahead and look at it in the X and Y, and we'll give this grid what are you doing, 12 feet?
Yeah.
All right, we'll just make the Y increment 12 because that'll be easy. That's a 12-foot line right there. Then we can go back over to here, and we'll kind of start up at the top and go down. So materials, it's already in there for you. All the wood stuff, we're using a Douglas fir number 2, right?
Yeah.
All right, and you have other options there. That's good. That's all you need. We're going to go to section set, and these are pre-set up. We're not. We'll go to wood, and for this case, you don't need any of this junk, so we'll go take it all away and just delete it. And then we'll just go right here. We'll call it. What do you want to do? What kind of post?
6x6.
6x6. So the name will match with the section. We'll go over here, and we're going to go to wood shapes, and then see wood shapes, and we'll go look for a 6x6. Pretty easy. Boom. Okay. So now we have dimensions in there. We know what this is. The design rule is not bottom chord. I don't know if there's a typical. We'll go to typical, and that's referring to design rule. We'll go look at that. What is design rule? Remember design rules. If you go look at typical, we're just saying, hey, max this out at 80%. Okay, that's all there is there. And then for deflection on beams, we have some stuff there.
We don't need the 360 number in there?
No. No, see, I don't know why that's on beams. I don't even know. I'm going to have to come back to this in a minute. All right. So then what we're going to do is we have the section set, boom, boom. We don't have wall design. I don't care about design, seismic design rules. I don't need to put node coordinates because as soon as I draw my member, I click the members, and I'm going to say, I'm going to call this a column. I'm going to select where I'm pulling from, the material. I want to go to shape database. I want to go to section set, and I have a 6x6, and I'm just going to go from here to here. Now I have a beam. There's all kinds of tools in here for labeling and like, okay, hey, it's member 1. Hey, it's a section set 6x6. I can go look at a bunch of things. Oh, hey, it's DF number 2. I can look at it multiple different ways. But the next thing I need to do in line here is seismic design rules, connection rules, node coordinates, boundary conditions. So how are we fixing this? Well, the column is going to be, first of all, we're going to do 2D. This is a 2D problem. No, is it? It's not a 2D. It's not a 2D. It's not. We're going to fix it on the bottom and fix it on top, correct?
Pin, right?
Yeah, pin. That's what I mean.
But that doesn't work in Risa, I thought.
No, we should be able to. Oops, what's going on here? So I turn the node labels on, and I want to. Let's see, boundary conditions. I'm going to say, oh, I didn't do this. It's pinned. Click to apply. Boom, and boom. Okay. So I'm fixing all 3 things. That beam can't rotate when it's fixed like that. So then the next thing I'm going to do is, what are your loads?
Try 150.
Okay. So, all right, and then there's nothing else here that's relevant. So let's go to 2x6, 12 foot, and which one? The bottom?
No,
Doesn't really matter. Doesn't matter. Doesn't matter.
Let's do the 12-foot wide one. So do 195.2.
Wait, what number? Oh, this. And it's out of plane. All right, so when you go to apply a load, in this case I'm going to do a running load, and I want to label it as, it doesn't matter which of these, but we're gonna just for the sake of this, we're going to say in the y direction, okay? So, I mean in the z direction.
I was about to say, y is the only one that doesn't work.
So we'll just do z, and we'll go boom, and
full length and magnitude.
Yeah. Anyway, full length and magnitude, and then we'll go 0.195. Okay, and click apply, and boom. Okay. Now, if I looked at this in ISO view, oops, I did the wrong thing. Oops, I did the wrong thing there too. Try it again. I'm gonna do it there, but I wanted this to be in the z direction. Okay. Now notice this is not in the z direction. It's when the load is like it's meant to be when you're doing 2D and this is plan view. When
it's just a label, isn't it?
it's a label. It's a label that represents the direction of the wind.
Right.
So we don't quite have the right application in this, but it doesn't matter. We can still. We're only doing one application anyway, right? The whole point is when you're doing a building and you have wind loads this way and a wind load this way, that's what we're doing, and this orientation of the grid will be different.
Yeah.
If that makes sense. So in this case, the z doesn't make a difference. It's just two different directions. So we'll just go with WAX instead, and it's in the z direction that we're applying this. Okay. Does that make sense?
Mm-hmm.
And there you go. And then the other thing you have is other stuff, right? You have I can't remember how we were doing this. You have vertical load.
Yeah, which is just to guess and check things. So just see if it even works now.
All right. So then what you do once you got here, and I've just gone down the things. My node coordinates got created right when I did the member, and that's boom boom. We did the boundaries. We don't have diaphragms. I don't need drift definitions in there. All the basic load cases were already set up. There's our load right there. And then we set up a point load, and now you're done, and then you run it. And all we really care about is running that one.
I think it was the first one.
Yeah. That's weird. Basic load case. We did 5. Oh, we want to do this. Wait, what am I doing? Load case. I'm very confused with that.
What are you confused about?
Basic load case. It's WAX CLR plus. Then when I go to run this, I don't see number 5. What is my head doing wrong? Oh, because these are basic load cases, not the load combination. That's the reason. Okay, so this is pulling load combinations right now. If I go look at the load combinations, these load combinations are what are pulling these are the combinations which are referring to these load cases. So these are all the load cases, like when there's not a label, like this is a label for wind load, but when I need to differentiate what it is, I have to use a number as opposed to dead load as this. So this is made by category. These ones down here are referring to the number of the load case. Does that make sense?
Mm-hmm.
If I come into here, I can do it from here or here. And because I have all these different kind of wind loads, I have to use a number instead. So when I go into here to run it, it's looking here and going, hey, which one is referencing 5? And it looks like I have
Number 6.
I have a mistake here.
You meant to line them up?
No. This load case.
Oh, it's set up for the wrong direction?
No. It's something that's a little bit goofy is that WAX is referring to 5,
Uh-huh.
and 5 over here is they're different labels. I've got them paired improperly. I gotta go fix that. So the question is, which one is referring to that? It's number 5. It really ends up being this one right here is number 6. They're not matching because of that mess up. Does that make sense?
Uh-huh.
But basically, I run it, and boom, hit solve, and it'll design that member. There are members defined as member type beam that are vertical or nearly vertical. Okay, let's go try that. So we'll go back up to members, and boom, we got a beam in there. This needs to be column instead. Now, why won't it let me change that type? So I'm going to click on the beam, additional properties, default.
Mm-hmm.
Oh. Come back up to materials, wood, no, section set, oh there it is right there, column. Now I need to try it. Okay, so once I ran the analysis, then I can look at it and look at the code and say, hey, how am I doing? Well, it tells me my bending check is 0.93. So it is working.
Kinda. Is that 93% of 80%, or is that?
93. It's 93% stressed.
Okay.
No. What it would do is it says, hey, if I go look at suggestion design, it's saying I need to make this bigger so that I can meet my design criteria.
What does it say to use?
4 by 12.
That's rough.
And here's another thing: when you work in, there's a lot of things in this program, and it's really cool. But there's some things to learn about it. And one of them is if you have different sizes, you want to see what orientation you're actually using, and so you can do a conceptual and look at it and see what rotation your member's at. But anyway, so that told us, if we go looked at the code check, it told us what stresses are there, so it's working. The next thing we want to do is check out and I just went to go to detailed report, click on this, and I want to see what kind of deflection I get. So there's my deflection right there, 0.9178.
That's
feet.
Not good.
Feet. Oh no, inches. Those are inches.
That's still not good.
Mm-hmm. Yeah. So that's not good. And they don't do any deflection. They have no deflection design on the column, I guess. So you have to do that manually, right?
Hmm?
You have to do that. Yeah, you have to do that deflection. I think manually. I don't think. Risa 3D provide deflection design on. I don't know. Anyway, does that? I mean, that's a very basic, quick